Now let's create our own application. In this example, we'll build a simple FM receiver. We'll start by visualizing the signal spectrum, then add an NCO and a resampler. Instead of using a standard FM demodulator, we'll create our own using a custom block. This will give you a deeper understanding of how FM reception and signal processing work. Go to the Projects page, click Create New Project, and name it. Enter Edit Mode. We'll start with the Block Diagram Editor. On the right sidebar, switch to Blocks mode. Drag in the WebUSB source block. This block reads data from supported USB devices and sends it as a data stream. Expand the block parameters. You'll see that a device parameter is required. We also need to set the frequency. Now we define the data source. Drag in the Source Select UI block. Connect its device output to the device input of the WebUSB source block. Then, open the parameters of the Source Select block. Set the caption. This is the label above the UI element. Also, enable USBs as an available source. Next, we need to set the center frequency. Drag in the Input UI block. Connect its output to the frequency parameter of the WebUSB source. Click the block and open its settings. Set a clear block ID. Set a caption as well. Choose a formatting function to display the frequency with units. Then set the default, minimum, maximum, and step values. Enable the interactive flag so the value can update while typing. Let's test what we've built so far. Select the device. Click Play to run. Check the Stats panel. If data is coming in, everything is working. Now let's display this data. Drag in the frequency sync block. Connect the output stream from the WebUSB source to the frequency sync input. Open the frequency sync parameters. It needs two things, canvas and rate. Get the rate from the WebUSB source block. Get the canvas from a UI canvas block. Give the canvas block a clear ID. Click Play again to test. Oops, we forgot to set the layout for the canvas block. While we're at it, set the alpha, fill, and grid options. These control how the graph looks. You can also set a title, but we'll skip that for now. Switch to layout mode. Stretch the canvas to fill the available space. Click Play again. Now the graph looks much better. Try changing the frequency. You'll see the graph update live. Let's add more advanced features. We'll add blocks to shift and isolate a portion of the spectrum. We'll use the NCO and resampler blocks, but instead of dragging them manually, let's copy them from another application. First, press Ctrl+S to save your current app. Go back to the Projects page. Open the FM Receiver app in edit mode. Hold Shift and select these 4 blocks. First, we have the Waterfall Sync block, named Waterfall Spectrum. It lets us select a region of the spectrum. Next is the NCO. It shifts the selected region to the center frequency. Then there's an Input block, named Tune Frequency Input. It shows the frequency of the selected region and lets us adjust it if needed. Finally, we have the Resampler, named FUR. It changes the sampling rate from the original signal to match the selected region in the waterfall spectrum. Press Ctrl+C to copy. Return to My Project. Switch to Edit mode. Click on an open area. Press Ctrl+V to paste. Here are the copied blocks. Move them into place. Delete any old or unused connections. Just select and press Delete. Now connect the new blocks to the output of the WebUSB source. You'll also need to connect the rate signal. Add a canvas block for the waterfall spectrum. Give it an informative ID. This block is required to display the spectrum on screen. Every functional block that outputs data must have a UI block to visualize it. Now, connect the frequency sync to the output of the resampler. Next, we could go ahead and connect the resampler. But first, let's check the output of the NCO. Instead of connecting the resampler, we'll hook up the frequency sync directly to the output of the NCO. We'll use the original sampling rate for now. Let's check what comes out of the NCO. No graph yet. We forgot to set the layout for the waterfall canvas. Go back to layout mode and fix that. Now test again. Try highlighting a signal in the spectrum. You should see it shift to the center frequency. The resampler allows us to isolate a narrow signal. Now connect the frequency sync to the resampler output. Also take the rate from the resampler. Click Play and test again. Try tuning to a radio station. The graph should now show the resampled signal. Try another station to compare. In the next part, we'll take it further. We'll add an FM demodulator and we'll build it as a custom block.